Hi Calculus student, this video is for 4.7 optimization part 2. So we continue with the third example. It's an open box example. So what happened is an open box is made from 24-inch by 36-inch piece of cardboard by removing square from each corner of the box and folding up the flaps on each side. You might have come across these kind of problems in pre-calculus where they will give you some piece of cardboard or paper, and then they suggest that if you cut the square of side length x from each of the four corners and fold it up, then you make a box that is an open box with no tops, and you can find the volume. So you can draw the box. After you fold it up, this would become, oh, then we have dimensions. So this is 24 inches and that's 36 inches. But because you cut off this two x values of square, so the size now become 36 minus 2x as well as 24 minus 2x, right? 1x from each side. So this is what it is at the bottom. And then the height would be x, because when you fold it up, that's what it becomes. And there's no tops. It's just like you just tape this and this together, and it becomes something that stands up. So if you cut too small, then the box will be too shallow and you do not have much volume. If you cut too much, then the box would have, the square itself would be really small and you don't have enough volume. So that should be a point where you have the maximum volume based on the size of the x. So what did they ask? What size square should be cut out? So we say it is x. It's very popular in pre-calculus. You have seen this also, to get a box with maximum volume. So we draw the picture, we assign all the variable, and unfortunately we only have one variable, which is the size of the square that you are cutting. So we are just to write the equation for maximum volume. What is this volume? If you look at this box, volume of a rectangular box is length, width, height multiplied together. So it will be x times 36 minus 2x times 24 minus 2x. If I multiply it out, I can multiply the first with 36x minus 2x squared times 24 minus 2x. And foiling it, I would have 36x times 24, which is x64x. 36 times 2x squared is minus 72x squared. 2x squared times 24 is minus 48x squared. And then 2x squared minus times 2x is plus 4x cubed. So all in all, if you combine like term, it's 4x cubed minus 72 and 48 add together is 120x squared. And then plus 864x. And we only have one variable, so we're ready to find the maximum. Oh, we have to actually look at what is the domain of this. Is it a closed interval or open interval? So obviously x cannot be 0, so it should be an open interval, right? So it'll be an open interval from 0 to, what's the maximum that you can cut? The shorter side has 24 inches, so the maximum you can cut is right in the middle, so just not 12, right? So this is the domain of what x is available. Now again, it is a open interval, so I don't want to do it. I just want to do a closed interval from 0 to 12, because I know that the endpoint cannot be the maximum, would not give me maximum volume, because the volume would be 0. So I just treat it as a absolute maximum problem. So and now we have to do reprime to find those critical values and then do a table, and that's it. Okay, reprime would be what? 12x squared. Let's do a prime of this, minus 240x plus x64. And then you can divide everything by, 0 equal to 12x squared minus 240x plus x64. and I divide everything by 12, so it'll be x squared minus 20x. I did it plus 72. Because x 64 divided by 12 is, so to solve this is not factorable. Okay, I try like 8 times 9, 12 times 6, but it doesn't go to negative 20. So use a quadratic formula, x equal to 20 plus and minus b squared, so it's 20 squared minus 4 times 72 times 1 all over 2. Okay, so I have two answers. You put it in your calculator, you would have 15.29. Yeah, doesn't write very well. And x is equal to also 4.71. Now you should save this number in your calculator, so when you do the next calculation you use this. Now this is not applicable. Why? Because our domain is up to 12 only, so this I only have one. So and this is the one where I would just do x is equal to 0 because it's at 12 and 4.71. Of course this is the maximum because all these would give me 0, right? The v would be 0, and then this give me what, 1825.3, and it is the absolute maximum in the interior, so it is the absolute maximum maximum for the open interval. So you would get maximum volume at 4.71, and then the maximum volume is 1825.30 inches cubed. Okay, inches cubed. So that's the open box question. Example 4. So the next question is about distance, about going to a place, and you can have two routes or you can have multiple routes. So what's the best route? So let's look at the question. A visitor planned to go from a cabin to an island which is 2 miles due north of its closest point along a straight shore. So draw a picture. That just means that there is an island here, and this island is on right? So on water, and the distance. So this is shoreline, the straight shore. This distance is 2 miles. The cabin is 6 miles west. Oh, should be. Oh, I should draw it west of it. So maybe I'll just draw it over here. West of the. So this is the cabin, and this is the island. The closest distance to the shore is 2 miles, and then the cabin is 6 miles west of that closest point, and this is 6 miles. And so how far would the visitor run before swimming to minimize the distance, the times it takes to reach the island? So, and then they say the rate the visitor runs is at a rate of 8 miles per hour. So this on here you can run 8 miles per hour. And if you swim, it would be 3 miles per hour. You of course you don't swim directly. So what happens is you will run a certain point up to here, and then you will swim across. Okay, so this would be, we assume that this is x. So I have to run 6 minus x, or the visitor runs 6 minus x, and then somehow you would swim y. Okay, so in a nutshell, maybe I'll draw it like this. So there's a right triangle here where it is 2 and then x and y, and this is the swimming distance. Okay, so minimize the time. So what is time? Time is how much it takes to run from the cabin to the point where you are starting to swim. So what is the distance? Distance is 6 minus x. And then what is the time? The time it takes would be divided by your speed. Your speed is 8, right? For that particular land trip. And then you have to swim. So you swim y divided by 3 because you swim at a rate of 3. So this is the total time it takes to go there. It depends on x and y. But of course, we have to simplify it into one variable. What is the things that we can relate x and y? So we can look at this. Oh, actually, you swim y, but the distance from where you drop off, jump into the water to the end of the closest point is x. We assign this to be x. So use Pythagorean theorem. So we are right on the top. X squared plus 2 squared is equal to y squared. So I mean, or y is equal to square root of x squared plus 4. Right? So we just replace this time. So this is all in terms of x now. 6 minus x over 8 plus square root of x squared plus 4 over 3. So this would will allow us to calculate what is the best time or what's the best distance to jump so that you can get there in the shortest time. So of course we and also what is the domain? Can I run all the way to 6? Yes, you can. Can I don't run and then just swim across right there? You can, right? So the domain is the x value could be 0. So x domain can be, just want to know if it is a closed interval or open interval. So it's a closed interval from 0 to 6, right? You can have this being 6 so that you jump right away, or you can run all the way to 6 miles and then swim across. So it can be from 0 to 6. So it's an absolute value problem in a closed interval, and these are continuous functions. So we are going to do t prime to find the critical number and do the table, and that's it. Right? T prime would be 6 minus x over 8. This you can imagine as negative 1/8 x, right? The 6 over 8 is just a constant. So it becomes 0 when you do take the derivative. So negative 1/8. And then plus, this has to do chain rule, square root of something. So be 1/2 of, the square root would be 1/2 minus 1 is negative 1/2. So the same thing, don't change it, x squared plus 4. And then chain rule of d dx of inside, which is 2x. Oh, and I still have the 1/3 times 1/3 is a constant multiple. So t prime, if I rewrite it nicer after you cancel this, will be negative 1/8 plus, is it a minus? Oh no, it's a plus. X over 3 square root of x squared plus 4. So if I solve this equal to 0, that means 1/8. So set it to 0 to solve critical point. So that means 1/8 equal to x over 3 square root of x squared plus 4. So proportion, you do 8x equal to this, right? So that means 8x is equal to 3 times x squared plus 4. To get rid of the radical, we will square with both sides. 64x squared. Square both sides, this become 9. And that square would cancel, will be x squared plus 4. So that means 64x squared equal to 9x squared plus 36. So minus 9x squared, I have enough space, minus 5x squared, I have 55x squared is equal to 36. And so x squared would be 36 over 55, square with both sides. X is equal to 0.809. So then we will build a table t and x from 0, 0.809 and 6. Oh, it's so small. Oh, do I have more space? Oh, I have space here. So maybe I'll just write it larger. So do it here, right? So 0.809 and 6, and I did it on decimal. I have typed the function, and then I have 0.6, 0.809, 1.36 is the lowest time. So this is the lowest time that you can do. And this is the time. So this is a distance where you would run. So run 6 minus 0.809, that much to get the maximum.